NotebookLM is one of the most popular tools for working with data and for purpose due to its unmatched ability to work with multimodal inputs such as text, images, videos, and audios, and as well its ability to generate the same variety of modalities, including quizzes, reports, videos, and others. And many people on the web call it second brain and magic, but it is just a technology. And today we will look deeper into the technology and dispel some of its magic, along with teaching you, dear watchers, how to properly use it. My name is Alex. I'm a PhD in artificial intelligence and the CEO of Blackthorn AI, where we more than for the 10 years develop different AI applications. NotebookLM consists of three layers. First is data ingestion or sources. You can see them here to the left. Second layer is interaction with the user. You can see it in the middle. This is a chat window. And the third layer is generation of output. You can see it to the right. It's a studio. Let's start from layer 1. Data ingestion. Here we can see that we can ingest websites, documents, audio, video, image, and a slideshow. For websites, NotebookLM quickly runs a check, is it public or not. If it's public, it goes to its MCP database or crawls the website to extract text. If it's not public, it gives you error. Let's use an example of a non-public website. This is my LinkedIn webpage, and if I add it to our notebook, I'll click Add Sources, I'll click Website, add my URL to my LinkedIn page. We will see that it cannot be added because the privacy policies for that website doesn't allow it to be added. Let's use some other resource. For example, let's use this archive page. Let's add sources, and it's been successfully added because it's totally public. Archive is a storage of a free of charge preprints to papers. We will look into this paper a little bit later in this video. What happens with the website resource after that? NotebookLM extracts text from the website, removes different HTML tags and other technical information, and then passes this text to Gemini to produce embeddings and store embeddings in the vector database. This is the essence, the core idea of the NotebookLM. This is why it's a Swiss knife and it can work with any modality. So any document you add, any audio, any video, image or slideshow, it ends up transformed to a text. Text is transformed by Gemini to embeddings, and embeddings is stored into a vector database, which is later used as a grounding for all generations. We will come to that part a little bit later. Now let's try to add a document. Click Add Sources, Upload Files. I exported this page about prompt engineering rules. It's a PDF document, so it will take a couple of moments to process, but overall we can see that it's been processed. We have a summary for that, and everything is fine. Documents are straightforward. Obviously, text extracted as it is and then transformed to the same way. Now let's try audio. For audio, Google uses its proprietary tool, speech to text. Again, let's click Add Sources. Let's click Upload Files. And here we have audio file. Let's add audio file. Again, it will take a while, but it will process the audio file. On the background, NotebookLM engine sends through API to another Google tool, which is speech to text. It turns the MP3 file to text and then sends this text to Gemini. Gemini transforms it to embeddings. Same thing with the video. Upload a video, and again click Sources, click Upload Files, and let's add a video, but it's large, and you will just believe me that it works. The audio stream is extracted from video, and then this audio track is transcoded to text. Again, text is transformed to embeddings. Same story. Now let's talk about images and slideshows. Images and slideshows are similar. They both processed through OCR, which is optical character recognition, and image captioning, to understand what are the objects on images. Let's first take a look at OCR. Here is the OCR result. So we have an image with words And this AI technology allows us to extract every symbol and consequently words from image. It works in two stages. Stage number one, trying to understand where the text is on image. You can see two layers of interconnected convolutional neural networks, which ends up with a dense block, which has two prediction heads. One is a probability map for the location of text on image. Another one contains probability thresholds for the borders. As a result, a binary mask extracted where the text is located, and the image is segmented with area covering text. Phase number two, this output is passed to the text recognizer. As you see, this part of an image, which has been recognized as text, passed into another neural network or set of neural networks, which slice this block of text into words. And then each word is passed to a recurrent neural network, which predict probability of each token. And then based on their probabilities, the final word is recognized. Like here from image state, we extracted text tokens state. This is how OCR works. As for image captioning is a human-like descriptions of an image. For example, if you try to get a snapshot of the video you see now, the caption will be a guy sitting in front of his MacBook and giving a lecture. Here we can see a natural scene of giraffes in the wild walking down the road. This image is passed to a convolutional neural network, convolved to some kind of embedding, and then passed to a second layer of recurrent neural networks like LSTMs you can see here that generate a text description of an image. Of course, this kind of neural networks is trained of a large corpora of images with aligned captions, and then it becomes smarter and then it can caption any image. In this way, images and slideshows converted to text. So as you see, anything that you upload to NotebookLM ends up being a text, and text ends up being passed to Gemini, and Gemini, because it's a proprietary Google technology, why using something else, right? They have their own nice vehicle, is turned into embeddings. Embeddings is just a vector representation of this text, some vector with numbers. It represents the data in the vector space. Why we need this? To then perform vector similarity search. To summarize, everything that you upload here on the left side of NotebookLM sources uploaded to a large vector database, and here phase one ends. Phase two is when user interacts with the data. Can you explain differences between zero-shot and few-shot prompting? What we are doing now, user entered a prompt. Modality is assumed from the prompt. The major source for this was this document about prompt engineering. It passed our prompt to Gemini to generate embeddings. Our embeddings also have some kind of coordinates, 10, 12, whatever. Our prompt means the text that we entered here, this text. So this text hit the vector database. And then a vector similarity search algorithm. It may be, for example, vector similarity, where our vector is multiplied as a dot product on all the vectors that are inside this database, represent the data that remains in this database. This similarity search found that the most relevant source is this one, and then in this source found parts of a text which are the most relevant to our prompt. Here we have references to these parts. If we click them, we can see that, okay, this part of a text related to this request. Number two, yeah, we can see the block about zero-shot prompt and one-shot prompt, right? And this is exactly what we asked about. We asked about zero-shot and few-shot prompting. So number one relates to prompting, number two to zero-shot, number three to few-shot, and number four, again, few-shot. Everything that vector search found in this database related to the most relevant source and most relevant data within the source. Then we receive an output. This output is grounded. The grounding is when the user's prompt is enriched with the context. So the things that you saw to the left when we clicked on the sources are context. The context that's been pulled from the vector database to enrich user prompt. This one. Now this database returns us our query enriched with the context, and Gemini can return much better response. We call it grounded. With grounding, LLMs do not hallucinate. That's a lie. They do hallucinate, but they hallucinate much less. And this is obvious benefit. Now, this is a layer 2. So we just understood how the prompting, how the chat works, and how does it interact with the sources. Now let's understand the final studio part. So the studio part consists of a number of modalities. We can generate audio, we can generate video, mind map, reports, flashcards, quiz, infographic, and data table. All this data will be grounded in the information that we provided to AI. Now, in the exact same way as my prompt went to the vector database, retrieved context, and was turned into enriched answer by Gemini, we can generate audio. Click Generate Audio, and NotebookLM will generate audio overview. Let's see how it works. So we just submitted to audio tool the same query with the context. Then it went to Gemini, and then we received answer. But we don't want it as a text. We want speech. This text goes to another Google tool, which is called text-to-speech. This is one of the Google products. You can try it in console, cloud, and in this case, it's invoked for generating nice audio for you. It requires a text to speak it. And then you can select the different models, locals, voice, and other things. If you click speak it,
Movies, oh my gosh, I just absolutely love them.
You will hear something like that. As inputs, it receives text to speak and the tone of voice. It took about 15 minutes to generate our audio. It used 6 sources. Maybe that's why it was so long. Let's listen to it.
Welcome back to the deep dive.
Hey, glad to be here.
Today we are taking you on a journey right into the invisible engine of our modern world. And obviously, I mean artificial intelligence.
Yeah, the big buzzword.
Right. Sneak involves defining a strict role. So you say, you are a nutritionist. Give me 3 tips for office workers who sit all day formatted as a bulleted list.
The venture capital space is clearly heavily invested in this infrastructure.
Essential molecules, like the nutrients our brain actually needs to survive.
It used all the 6 sources that we provided, and these sources are very scattered in their topics. For example, this one talks about startups. This one about AI startups being recently funded. This one talks about very specific technology of molecules crossing the blood-brain barrier. That's why speakers use words like crossing, shuttles. This article describes a prompting approaches. That's why you hear words zero, one shot, and others. And this paper is about computer vision technologies, like architectures of neural networks. The one that I showed you, I took them from this paper. That's why the speakers use words like complex architectures, neural networks. The NotebookLM is very straightforward. And this is the major thing you have to keep in mind. Everything that you gave it, it takes for a word. It trusts you as an expert that you know what you want, and then it mixes all the context in a speech. For example, if I wanted it to talk about only prompting, I should deselect all of these irrelevant sources. Let's try once again. Let's listen to it.
That moment where you type a question into an AI tool and you're expecting some mind-blowing, brilliant answer, and instead you get a response that is just
completely generic.
Yes,
Talking about prompts.
And completely control the tone, the length, and the structure.
Talking about prompts.
Brilliant. First, it explicitly assigns a role. You are a nutritionist.
Right.
Talking about the prompts.
That requires rule number 4, break tasks into steps.
Talks about the rules of prompting.
Exact same principles to build a fully functional website using a feature called Claude Artifacts with just...
Talks about creating website, part of that page. Perfect. We've got what we wanted. Now we generated a podcast about only one source that we selected here. So if you want to generate something that relates to not all sources, but a part of the sources, explicitly select them. And NotebookLM will do exactly what you want. And the vice versa. If you drop on irrelevant sources, your result will be messy. We will continue with other modalities like mind map. Mind map, the approach is technically the same. It takes your query, goes to a vector database, retrieves context, gives it to Gemini. Gemini generates answer, and then answer is passed to one of the tools on Google Marketplace. I cannot promise that this is exactly that tool, but something like that. Let's get back to our notebook and generate mind map. Pay attention that now only the prompting source is selected, so all of the rest sources will be ignored. Let's generate mind map. It was fast. Let's open the mind map. We got exactly what we wanted. We wanted mind map related to prompt engineering. We have prompt engineering, fundamental, structuring rules, prompt techniques, common mistakes, practical applications. Definition, bad, good prompts, structuring rules, prompting techniques, common mistakes, practical applications. For videos, we have the same approach. Google uses some other tools from its workspace, AI-powered video creation. It's based on VO3. The mind map was great. Now let's try to generate short video. I don't want a long video because it will take us eternity. So I can go to settings, configure notebook, and I want my response length shorter. In this way, it will take it less time to generate. Also, see here, I can tune my conversational goal, like it's default, learning guide, or custom. Let it be default for now. After setting up a shorter answer, let's generate video. We will use English. Let's select some style brief, small one, just for the sake of time. While our video is still processing, let's explore other modalities. Let's generate reports. Briefing doc will be fine. Let's generate flashcards, quiz, and let's generate infographics, all for our article about prompting, and a data table. So we have a briefing doc, strategic overview of prompt engineering best practices, fundamentals of prompting, framework for structuring prompting, effective, ineffective, role and context, desired response format, comparison, well-structured information, looks like a real report. Let's get back to the studio. Flashcards. It's a cards for studying. Great idea. What is the core purpose of prompt engineering? Like generate better prompts, creating effective prompts. Nice. Got it right. Why is be specific a fundamental principle of prompt engineering? Because of hallucination. If you're unspecific, you will get unspecific answer. Models provide more relevant answers to clearly formulated requests. Correct. Great. This is the idea of flashcards. Quiz. What is the primary objective of prompt engineering when interacting with models like ChatGPT? To obtain accurate responses. That's correct. Great. We have 10 questions generated out of the article body, useful for any teacher or lecturer. Love it. Then we have data table. I adapted that it can generate the data table. It did generate methodology, description, key elements, positive example, negative example, use case scenarios, and expected output format. Nice. And also source. Pay attention. It gave us a source. I used one source intentionally. I didn't want to use messy sources. You saw the result. Mastering AI prompts.
Are you tired of getting those super generic, kind of useless answers from AI?
About prompts.
We've all been. The craft of writing these powerful instructions actually has a name.
About prompts.
Okay, rule 3. Don't just tell the AI
About prompts.
By doing this, you're pretty much guaranteeing a well-organized, easy-to-read response.
All the video about prompts. That's why, friends, be careful with the data you provide to AI. It will return you the results grounded in that data, not something you thought about but didn't tell it explicitly. Probably the last thing that you need to know about NotebookLM is its ability to integrate with Gemini. And if we click plus, we will see NotebookLM option. If you click on NotebookLM option, you will see the list of notebooks. This is ours. Can you summarize the notebook content? We'll just double check that it can access the content. Right, this is our notebook. PPOCR, a practical ultra lightweight OCR system, was the first paper that been added here. The documents, biotechnology, drug delivery, brain shuttles, AI startup, investment trends. See, all of the sources are grouped into 3 groups. That's true, that's real sources that we added. This one, Manifold, is about brain shuttles. This paper is about neural networks and OCR. And this is about prompt engineering. And this is about startups. Intentionally mess. NotebookLM is a Swiss knife for data. It can digest images, text, online resources, infographics, tables, pretty much everything that exists in the digital world, except very specified domains. But it's not a magic, and do not expect magic from it. If something you are asking is not in the data you provided, it will not give it to you. It will even not hallucinate it to you. The creativity of NotebookLM was intentionally lowered. It acts as a data extractor and aggregator and less like a creator. If you want a creator, go to Gemini, go to ChatGPT and other general purpose LLMs. Second side of this coin is if you give it too much data, your answer will be messy and too generic, composed of too many conflicting parts. Like in this video, you saw it with audio podcasts, right? It jumped between topics on many sources. They were also showcasing different, very unrelated parts of the data. NotebookLM, at the very end, it's a vector database with data which provides grounding for Gemini and related tools. Grounding reduces amount of hallucinations, but it does not eliminate them entirely. So you can expect it to be very precise, but not 100% precise, not 100% accurate. It may miss both some things in outputs and some things reading inputs. We worked with small documents and actually you saw the results were pretty much comprehensive. But when you work with 1,000-page documents, hundreds of thousands pages documents, then obviously some information may be missed due to context window and some other things. So be careful. You saw how easy we integrated Gemini with NotebookLM. In this setup, NotebookLM serves as a database, as a data source for Gemini. You also saw how all modalities, all inputs at the very end are turned into text and stored in the vector database. In this way, NotebookLM and other Google Stack can relate information between different modalities by turning them first to embeddings and storing them in the vector database. This is a general approach to unifying the data in multimodal systems. One more feature that needs to be mentioned is NotebookLM can perform search, simple, brief search, web, and deep search. This functionality is similar to Perplexity. But the most prominent thing is that it is free of charge. I wonder how many startups Google killed this time, but obviously at no price there is no match for this tool. Thank you for staying with me and see you in other videos. Bye!